Hello everyone, this is the very first tutorial about Avatar SDK Unity plugin. Today I will show you how to basically get started with the plugin. I will demonstrate some of the basic functions. So let's go. First of all, I will import the Unity package into my empty Unity project. You will of course download it from the asset store. I already have it in my local file system, of course. It will take a while to decompress the plugin. It has quite a lot of files. Some of them are related to the machine learning algorithms. Also, we have a number of predefined FBX animations for the samples, facial animations. Okay, it's already done. Right after the project is imported for the very first time, the important things happens. The plugin unpacks and places a folder called streaming assets directly into your project root in the asset folder. Make sure that this folder is created for you and it contains like folder avatar underscore SDK in it, and it has a lot of files like this. These files are needed for the deep learning algorithm of avatar generation, and it won't work without them. And this folder must be in the project root. Without it, Unity won't interpret it as a streaming assets if it's not placed directly in the assets folder. You can read about it in the Unity documentation. Okay, this one is covered. Obviously, first thing that you want to do when you import any plugin is to look at the sample scenes. This plugin provides two sample scenes. First of all, let's take a look at the getting started scene. This scene is very simple. Its main objective is to provide you with bare bones, very simple sample that doesn't have any distractions like complicated UI or anything, just so you could look at the code and see what is needed to enable avatar generation in your project. There are two options: generate avatar from predefined photo and generate avatar, like load the photo from your file system. Let's choose the first option this time. It loads my photo, and it will take like around 10 seconds to generate avatar, and it's done. You can see the 3D model of my head is generated from just this photo and place it into the scene. This is all this scene contains, and there is no point looking at it any further. Let's open the second scene instead. Okay, this scene is a little bit more complicated. It shows like all avatars you have already generated on this computer, and also offers you two options. Let's select this one this time to load the photo from the file system. I have a folder with photos of my colleagues. Let's choose Ilya, and like we'll generate a couple of photos. This one is okay. You can generate an arbitrary number of avatars at the same time, as long as you have RAM to support the calculations. As you saw, like two of them were calculating simultaneously. Okay, let's take a look. This is the avatar we got. And this sample has a little bit more controls. This panel controls the facial animations. You can play back different animations, switch to the next one, etc. This one will allow you to change the haircuts. We have 6 predefined haircuts at the moment, and of course we want to add more in the next versions of the plugin. And also SDK allows you to change the color, the tint of the haircut to the arbitrary color. All the crazy colors are supported. Okay, this is an example with an unlit shader. without it doesn't matter what light sources you use, it will always render the same with the diffuse texture. We also can select lead shader, and there is also an example how to do instantiations or create several objects from the same mesh without spending calculation resources on every object. This is purely done on GPU by Unity. Okay, and also I wanted to show you how to play with blend shapes. Let's open another avatar, like select some kind of haircut, and open scene view instead. If you select the model, of course it has a skinned mesh renderer component because it is an animated mesh. If you disable the animator, you can play with the individual blend shapes like in runtime. For example, we can make this avatar smile or do some weird things. If you set various blend shapes coefficient, we can make it open its mouth, etc. Okay, so these are the sample scenes that plugin provides. Again, you can find them in samples local folder in the project. What else? When the plugin is installed for the first time, it will unpack the documentation, and you can access it at any time through this menu window, Avatar SDK documentation. It will contain the documentation in HTML format. This is a requirement by Unity, like every new plugin with scripts should contain full reference in this kind of format. It contains this start page with some useful links, getting started instructions, frequently asked questions, and stuff like that. Of course, it also contains like a full reference to the classes and methods that are used in the plugin. You can look at it at any time if you find it useful. Okay, let me cover the first question from the frequently asked questions. Of course, this is like everybody asks how to attach the 3D heads to their full body characters to generate full body avatars. Currently we do not have the sample that does it, but we will have like in the next version or so. But even now it can be done. It's actually pretty easy to attach the head to the full body model. All you need to do is to find an arbitrary 3D body with a skeleton, detach a head from it with some kind of 3D editor, and import it to Unity. Then you should write like a simple C# script to set a bone weight of 1 to every vertex in the generated 3D head, and a bone index should be equal to the index of neck or head bone in your skeleton. So the bone that usually head is attached to. Usually this bone is called head or something like that. Once you do this, it will rigidly attach the head to the body, and if you do everything right, you should get a result something like that. As you can see, it animates okay, and of course you will have a problem with the seam between the neck and the body, and you will need to cover it somehow with a collar or something like that, like it's done in this model. We want to address this issue in the future as well and provide some algorithms to merge neck with the rest of the body, but yes, this is how it works at the moment. Another thing I wanted to cover is like everybody asks where avatars are placed in the file system, how to like get a 3D model. I will show you on my computer. This folder is here you need to go to application data, local low, then to your company and to the name of the project in Unity. And if you select the correct directory, it will have avatars in it, and you can open any of the avatars folders, and it will have like all the files that I needed to display the avatar in a scene. This model head bolt, for example, is a mesh. So yeah, I opened it in software called MeshLab. Yeah, so this is how it looks like. With this tool MeshLab, you can convert it, for example, to OBJ, import it to Blender, to 3D Max, and do anything you want with it. Okay, probably the last thing I wanted to cover is how it actually looks like in the code. Let's again take a look at the getting started sample. When we press this button, it calls the function that is like called generate and display head. It accepts an object of the class raw photo, which is just basically a collection of pixels and width and height of your image. You can obtain this data from any texture 2D in Unity or from JPEG or PNG image, and the code in the getting started sample actually even shows how to do this in these two functions. Let's take a look at the code. There are a couple of important calls here. First of all, you should call initialize avatar with this argument photo. It will create a folder in your file system where I showed you with this photo, with a proper name, with a proper format for further algorithms to work. Then you should calculate avatar locally. This function will start actual calculations, the deep learning algorithm, and after it's completed, you should call load animated avatar. It will import the files from the disk and into memory. I think it returns an object of type textured mesh, which is basically mesh and texture together. And when you get this textured mesh, you can display it in the scene. This is a familiar Unity code, nothing special here. There are a couple of interesting things about the plugin implementation. First of all, to call basically any request, you should have an object of type session. In this example, it is created when this mono behavior is created, right, in the constructor. And you should also always call dispose for this object, because otherwise you'll have memory leaks or other nested stuff. And before you can start using any of the requests, in start method you should call initialize session, which basically calls initialize on the session object. And you won't be able to call any of these methods until the session fully initializes. In this simple sample, we just wait until the session initializes before proceed further in the code. This is because while session initializes, it loads native libraries into memory and also some of the resources needed for the deep learning algorithm, and none of the methods will work before you initialize the session. And second interesting thing is that basically every function in the SDK, it doesn't return actually the object you want to get from the function. Instead, it returns an object of class sync request. This is also a part of SDK. Basically, this is a wrapper object around any type that is inherited from custom yield instruction. This is a Unity provided type that has this kind of property, keep waiting, and the yield mechanism in the coroutines depends on this keep waiting method. Basically, anything that overrides keep waiting, you can yield on it in a coroutine, like just like that. Um, in this sample, we instead wait on the return value of the await function, but it doesn't really matter. This function just basically wraps this request object with a while loop and updates the progress on the screen when the progress changes. If you don't need progress, you can just basically omit the wrapper function and yield directly on the requests object. Why is it done so? The alternative would be to use standard callbacks, but if we went with callbacks, you wouldn't be able to write sequential code like this. As you can see, this method is fully asynchronous. It will asynchronously initialize avatar, it will asynchronously calculate an avatar without blocking the main thread. And if you used callbacks instead, we would have like 10 different functions. With coroutines, we can write it much more easily just in a single function. Everything very simple. So I think that's all for today. If you have any questions, please post the comments below the video or write to our support. I will put the links in the description of the video. I hope this is not the last tutorial, and okay, enjoy Avatar SDK. Goodbye.